there's the questions. I'm not going to focus on 7. I'm going to focus on, think what, 9B, 9C, 10A. Briefly go over 10A and 10B. I'm just going to cover how your calculations change when you change variables inside your charts. So I'm not going to dive into a complete question 10 thing, but I'm just going to go over a couple things to help you answer question 10. So the question, let me go to chapter 4, and I actually did not read. Whoops, I didn't put the question. I guess I probably should have. So question 9, they give you a demand scenario, and the demand scenario. Oh yeah, before I start, the appendix C. Actually, page 490 is the wrong page. It's like 494, 496. So don't be confused. Has 2 files that they give you. I did put them in in a discussion in case you want them, so you don't have to worry about it. Because some students have problems getting them. Some people get the books online, and the links aren't that easy to get to. So I just put them on the class. But what I do is I create a spreadsheet, and I make a spreadsheet. Mine looks like this. I'm going to pop it up here real quick. And basically, let me shrink this down a little bit so it fits better. So basically, I just put all my calculations in my spreadsheet. When you get to week 7, this will make sense. But basically, you've got your quantities, your weighted demands. Then I just have a calculation that just this times this, and this gives you all your calculations as it is per the problem. So this is helpful because what this lets you do is this lets you play with the numbers a bit. And in real life, I've used these in one of my assignments where I was having to do this for a repair facility, where you can play with the numbers and see where things lie. Like, for instance, in this here, the profit for the distributor maxes out at 19,000. So the distributor is going to be incentivized to have 1,900 things on supply. Okay, so they're going to order 1,900. So, and the manufacturer, if it's a make to stock, the manufacturer is going to maximize their profitability. Now, theirs is a little bit different because so in this example, they're basically gonna build as much as they can because they but the manufacturer will only build what is ordered, because this chart here doesn't take into consideration buyback costs. Here it does here, but I'll go through this in a minute. I don't want to confuse you, but what I'm trying to say, basically, if you make a spreadsheet, I think it makes you better understand the information. So this is what I used, and going forward, I'm going to prop this up and want to go over question 10. So you have they give you a demand forecast. Demand scenario gives you quantity and the probability, and they basically ask you. Let's see. Okay, the first one, it tells you that the manufacturer builds for $20 a unit. Selling price for the retail is $50 a unit. Salvage cost is $10 a unit. So they want you to figure out what the profit margin is. You know, how many units will the manufacturer build, and how many units will the distributor order. So in B, suppose manufacturer is make to order. So the timing of the events is as follows. You know, distributor orders it before it receives demand from end customers. The manufacturer produces the amount ordered by the distributor, and the customer demand is observed. So it's a general make-to-order contract. It's nothing surprising. So they say, what is the expected profit for the manufacturer and the distributor? So in this example, I basically have a forecast between 2,000 and 2,700, and this is the probabilities that was assigned to it by by the retailer. So the manufacturer builds each item at a $20 cost each. The retailer sells it at $50, and then there's a salvage cost for unsold items at $10 a unit. Okay. So, okay, I guess I did write it down. So, so then the manufacturer sells to the distributor at $40 a unit. Okay, I'm going to go to the, okay, then question 10, suppose the manufacturer has an inflated demand forecast. So this is the inflated demand forecast that I'm going to cover in question 10 in a minute. So I should have probably moved this down a little bit, sorry. So let's do question 9B1, cost to the distributor. So in this example, manufacturer sells to the distributor $40 a unit. How much will the distributor order? So this is really simple. First thing that we gotta do is we gotta find, looks like, okay, hold on a minute. Let me make sure I didn't miss anything. So basically all I did here is basically the distributor, this basically shows what the cost and the profit is. It's very simple. Basically you go revenue, quantity times selling price, cost is quantity times cost, and profit is revenue minus cost. These are very general calculations. So the quantity is this line here, category, times the selling price. The selling price is $50 each, so that's the revenue for the distributor. The cost is the quantity times the cost per unit. I use $40 per unit in my example. So then profit equals revenue minus cost. So now when we talk about what the distributor will order, we do what is called a weighted probability, weighted demand calculation. And basically, did I put that here? No, I didn't. I kind of did. So basically, to calculate your weighted quantities, all you're going to do is multiply your quantity times your probability, and then you add up all the quantities. So in this example, let me bring up, for some reason it didn't make it in my presentation. In this example here, the distributor will order 1,840 units because this is the most likely amount of units that he will sell. Okay. So, and that's basically done by multiplying each of these numbers by 5%. 1,500 by 5% gives you 75. You add all these up, and that gives you 1,840. So 1,840 is right there. Okay. So the distributor is most likely to order that, and then and sometimes the students will say 1,900 because we order by lots. So if you put down 1,900 as an example, and as like this example states, that'll be fine. Okay. Okay. And then all you do is, once you figure out what the weighted value is, you just go your 1,900 and the revenue. So it's right here. So you got 1,900. Revenue is 95,000, cost 76,000. Their profit's 19,000. The distributor will only order. This is not doing anything as far as salvage costs. Basically, it's basically how much will the distributor order without any salvage costs involved. So this would be right. So this would be the number right here. Now the cost of the manufacturer. When you calculate costs to the manufacturer, it's remember to important that the selling price that the manufacturer sells to is the distributor cost. So when you hear that the distributor buys it from the manufacturer for $30, $40, that's the manufacturer's selling price. It's not very clear in the assignment. So when we look at the cost to the manufacturer, we look at it as if the distributor orders 1,900 units. So basically, it's it right here. You have a cost and the profit. Okay. So you just go to the amount that the distributor orders, and that's how much the manufacturer will make. Because the manufacturer will only build as much as a distributor orders, and this distributor will only order as much as they plan, as much as they can sell without losing money. Okay. Okay, so maybe I did go through. So in 9B1, basically, this basically shows you how I calculated the weighted value. I just went over it. So in this example, the manufacturer profit is 38,000, which came from here, 1,900. Manufacturer profit is 38,000. And the distributor profit will be, whoops. The distributor profit will be 19,000, as it states here. So as it states here, the weighted value is quantity times probability. You just add up all the weighted values. Yeah. And then take the profits from each chart for 1,900 units. Now, in 9B-2, you look for an option contract such that both the manufacturer and the distributor enjoy a higher expected profit than B1. It doesn't give you a contract to use. It basically says just select one. So what is the expected profit for the manufacturer and the distributor? So it's important to remember on this problem that the manufacturer takes on the additional risk in order to encourage the distributor to sell more. One of the caveats of this type of order system is that the distributor will only buy as much as they can comfortably sell and still make the most profit possible. So the manufacturer is going to try to get the distributor to buy more products from them to encourage them to attempt to sell more products. In my example, I just picked, two incentives you can use. You can use a buyback contract and the revenue sharing. These are probably the easiest ones to use for this problem. Buyback is where the manufacturer offers to buy back unsold inventory. In this example, you use your salvage costs. Revenue sharing, percentage revenue from what manufacturer is shared with the buyer, usually in form of a lower wholesale cost. And in this case, what you would do is if you wanted to use this in your different levels of your demand, you would just put the sale price lower. Like for instance, if you notice in this is the manufacturer. Let me go to the manufacturer. If you notice here, I basically this isn't okay. Revenue. Well, this is wrong. This should be weighted. This is done wrong. But basically, you would look at the revenue, and revenue is calculated by quantity times price to the distributor. What you would do, let's say if at 2,000 you decided that you want to sell it for $10 less, you would just put in. Let me see if oh, here we go. Let me pull up my spreadsheet here. So, using this example here, let's say that the manufacturer wanted to do a revenue sharing where he drops the price of each item. What was my assumptions here? Okay, costs. So right now he sells them for $40 a piece. Let's say that he wants to go to $30 a piece. After he buys 2,000 units, all you would do is at 2,100, you would just change your revenue to whatever the new price that the manufacturer offers. So the revenue would go down, and obviously when the revenue goes down, your profit will go down also. But then you look at the distributor. In this case, the cost would be lower. Because in this example, if we go from 40 to 30, you would go 2,000 times 30. So in this example, the cost would go lower, so their profit will go up. So their profit will go up because the revenue will stay the same because the selling price is the same, but the cost to the manufacturer, cost to the distributor will go down. So the profit will go up. You could do things like rebates, and in a rebate you just change the cost, change the selling price. You change selling price to 45, and then you can change whatever revenues you want. So using these three numbers, you could change these charts to determine, to make whatever type of risk sharing that you want. Does that make sense?
Yes.
Okay. And you can just take your pick. That's just three examples. You know, rebates, buyback, and revenue sharing. And if you have a spreadsheet like this, it's really easy to just change the numbers around based upon what you want to incentivize. Okay. I got to change these labels on this. Obviously, it didn't cut and paste very well. So I think we just talked about that. Okay, cost manufacturer. Where were we? Okay. So in my example, I basically said, look, I was going to have a buyback of unsold items at $15. Okay, and in real life, the buyback rate is usually set between the salvage cost and the manufacturer cost, because the manufacturer doesn't want to salvage things above cost, obviously. So buyback must be above salvage cost for the distributor to actually want to do it. So because if the manufacturer sets the buyback at under the salvage cost for the distributor's not going to do anything because the salvage cost is actually more profitable. So in my example, using buyback, the profit for the manufacturer would be the revenue at the 1,900 units as before, minus the cost per quantity minus the buyback cost. In this factor, I added the buyback cost to here. And all I did was, after 1,900, for every unit that is not sold, because we're assuming that 1,900 is like, that's the optimal point for the distributor to order goods. So we're saying that if the distributor meets 1,900 but has these 100 units left over, we're going to buy these back. So when you do this, the buyback cost is subtracted from the manufacturer's profit, added to the distributor's profit. So if you notice here, the profit margins go down for the manufacturer, and the profits for the distributor go up the same amount. So this is where you basically, where the manufacturer shares some of their profit to the distributor in an attempt to change the quote-unquote sweet spot. In this example, it didn't do it because the profit is still best at 1,900. But if you raise the buyback cost, you can keep bumping it up until, you know, let's say if the buyback cost is $30, you know, then the buyback cost here would be so it probably would be 15,000 plus 4,500, so that'd be 19,500. In which case, now, if the buyback cost was $30, he would be incentivized to place an order for 2,000 now, because you basically mitigated the risk for the 100 units. Does that make sense? Okay. I assume so. Hopefully I didn't put him to sleep. Okay, so I think that was, okay, 9C. So 9C is pretty much the same thing. So now we're going to look at it from a make to stock standpoint instead of a make to order. The numbers are all the same, except for now the factors are different. The manufacturer will build as little as possible to reduce risk, and the distributor will have to incentivize the manufacturer.
Excuse me, Ken?
Yes.
Quick question. So when we're talking about buyback, it makes me think of restocking, meaning that unsold inventory from a distributor or retailer that they want to return. How does this, maybe we're going to get to it, how does this, I guess, work into the whole equation and environment?
Okay, in a buyback, basically what the manufacturer is saying is for every unit that is not sold,
Mm-hmm.
we'll buy it back. And in this example, the buyback was set at $15. It's a very arbitrary number. It's just one that I just picked.
Yep, no, that's the whole buyback is clear.
Okay.
My question is around if, let's say, a distributor or if a seller returns inventory that they can't sell and they're assessed a restocking fee. You know what I'm saying?
Oh yeah. Well, you're right. That would be in a contract. And I think earlier in
And I don't want to.
yeah, no. If you wanted to do that, you could actually either you could add the restocking fee cost to the buyback cost, or the manufacturer just may say, hey, look, we're going to waive the restocking cost.
Or reduce the amount that they're going to pay back based on what they charge for restock.
Correct.
Okay.
They could, yeah. And that's a good question. In a real world, scenario, and I've seen it, especially with like rebates. We'll say, hey, look, because you have all this product, we'll waive the restocking fee, and in a bid for you to pocket that restocking fee and encourage you to sell more goods or to take on more risk. But usually that's
well, I've seen a distributor charge a sell-through retailer a fee for returning product that they weren't able to sell, but they actually bought, and they charged them to return it to them.
Oh, sure. I have too. This example only talks about manufacturer and distributor. So you're right.
Yeah, so
you may have a retailer up ahead that relationship between the distributor and the retailer.
right.
That's very possible. Sure. And that happens a lot. Although I've talked to some distributors lately, they're moving away from that because there's so much competition with distributors that a lot of the retailers are not willing to pay restocking fees anymore. So as a result, distributors are having to either swallow it or add that into the pricing.
Yep, gotcha. Okay. No, thank you. Sorry to sidetrack.
No, not at all. I love sidetracks. So now in 9C, we're basically going to flip it over so that now the risk is being felt on the manufacturer, and the distributor has to incentivize the manufacturer. So now the manufacturer will have to factor in salvage costs in their calculations. So this is the same chart as before. So, but this time the manufacturer, you're going to look for the most profitable point for the manufacturer. In this example, based upon the numbers I used, the
1900.
It's 1900. So the manufacturer will see the highest profit, making a little based on the expected demand. So basically, the distributor basically says, "Hey, look, we will." They're not willing to basically guarantee an amount that they will buy, but so the manufacturer basically is going to say, "Well, basically, based upon your demand forecasting, since you're most likely going to make 1900, when you factor in the salvage costs, which in this case, I factor in salvage costs of $10 a unit. When you factor in salvage cost and the most likely probability of selling 1,900 units, as was before, our best profitability is at 1,900. And that makes sense. Makes sense. So now the distributor is going to try to incentivize the manufacturer to make more goods. And I use the buyback again just for ease of calculations. So in this case, the buyback profit, in this case, the distributor subtracts the buyback cost from their profit, and they shift that profitability to the manufacturer. Okay? That's all that's changed. Does that make sense?
Yes.
Okay. So the manufacturer in this scenario, the manufacturer is still going to make 1,900. But if I was a distributor, I go, well, you know what? I'm only $500 away from making this actually profitable for him, so I may bump. Well, it looks like here he has to make it at least $20 a piece buyback cost. So he gets 2,000, and then this makes it 38,000. So it has to be at least $20 a unit for this to be profitable for the manufacturer to take on more risk and make 2,000. You see that?
Yes.
Okay. And so in question 10, they basically say, okay, the question is basically they ask you to discuss the effects of inflated demand on each party's decisions. So I'm going to pull up this spreadsheet. This is going to be pretty obvious, but if we increase the amount, okay, I'm just going to toss in an arbitrary amount. Okay, now the let's see, let's do, no, I don't want, are all my small, okay, let's ignore the buyback. What's it going to do profit here? Okay, so right now the profit without buyback costs, we're not going to worry about buyback costs, the profit is 1,900, same as before, okay, because the highest level profitability is right at 1,900 for the distributor. If I increase this to say 2,000, whoops, oh yeah, that's right, okay, so I'll just do equals this plus 100 and just drag all these down. Okay, so if you notice, the weighted demand is 2340, so it's 2,400. So, but it's still at the exact same spot. Okay, exact same spot. And this is because whenever you have demand increase and the intervals between each of your brackets is the same, obviously the whole bracket's going to shift. Now let's say that we want to change it. I thought I had one where I had, maybe I didn't. Okay, I'll go back to one I had. So I'll put it back to 1,500. Now let's say that we change these weights. Let me see real quick. Equals sum.
So say that you're going to post the spreadsheet.
I can. I can post it. So
I mean, it's all the same data versus going back and just rebuilding it, and, you know.
Correct. Yeah. I actually have the answers in these two tabs here, so I'll pull those tabs out for obvious reasons. But yeah, I could send this, and you guys can just play with it if you guys can understand my my chicken scratches. But
well,
yeah.
I understand, yeah, everything that you're talking about and manipulating the quantities, and I can see the effects of the formulas.
So yeah.
And
so
thinking about going through all of the data set that's provided for the assignment, instead of redoing everything that you've already done, not asking for the answers, but just a tool is really
sure.
I think
Yeah, because what they give you in the book is nice, but it's a bit lanky. It's really, I used it the first time. I'm going, wow, this is way too much. It's a huge spreadsheet and it's really big. So I ended up just making this myself. So in this case, if you move the probabilities around, obviously the break-even point, the profit this example actually is 1850. So the number of units went up a little bit. But let's say that if we just made this 15, and made this 15, and made this 11, you can see how, or even just make this 30, or let's say 10. Let's say this 10 and 7 and whatever, 12, whatever, doesn't really matter. Your weights are still going, the weights have more of an effect on the profitability than the actual amounts do. So it's pretty obvious, like let's say if I made this 30%, I made this 10, I'm just going to just drop some numbers in here until it's 16. Okay. So it's just based on the distribution. So now I made it. So now it's at 1800 instead. So the effects of your probabilities are far greater on the profitability than your weights are, than your quantities are. So inflated demand isn't going to change the location in that chart where that sweet spot is. The probability will, but the inflated demand, as long as each of the spaces between the variables are the same, it won't change much. So just keep that in mind when you answer question 10. Okay. So yeah, I will clean this up at work tomorrow, and I'll post this. Let me see. I just want to close this. Don't save the changes. So yeah, people get tripped up because they get kind of caught up into the spreadsheet. And as long as you understand how each of these items fit into this chart, you should be fine. So, manufacturing cost, distributor cost, which is the selling price for the manufacturer. Selling price is what the distributor sells it to the retailer. Then the salvage cost is price of, cost of unsold goods that is borne by the manufacturer or by the distributor, depending upon the type of contract you're looking at. And then all you do is just look at the different type of contract, make to stock or make to order. In one of them, the manufacturer has all the risk, and the other one, the distributor has all the risk, and calculate accordingly.